Here's something else that really concerns the U.S. Geological Survey. You're taking millions of gallons of water and frac fluid, and you're putting it down there. What the hell is happening to all that water? We know that some of it is produced back. You know, might be some 40, 50, 60% in some cases. Varies from formation to formation. But what the hell is happening to all the stuff that we leave down there? Where's it going? Scientists at the U.S. Geological Survey don't know, and they think it's a pretty damn important question. Now, are regulators concerned about this? Well, not really. It doesn't seem to be. So one frac is using enough water, fresh water, surface water or groundwater, to serve between 11,000 and 55,000 Canadians. And again, then industry and government wonder why Quebec said no to this. Why New Brunswick is, and folks in Nova Scotia are upset about this. And here's the trend for fracs. All right, it's not one frac. There's no frac once. Take a look at Eagle Ford Shale. All right, that's a tight old play right in the middle there. So how many times are they fracking? Up to 20 times per well. If you're using 5 million gallons, that's 100 million gallons per well. Where the hell is that water coming from? Now, the United States Geological Survey, marvelous scientific institution in the United States. Here's what they're saying about what are some of the water issues. You know, the most important scientific body in the United States. Direct impact subversive incidents, loss of control during hydraulic fracturing, groundwater contamination, release to surface of gas, contaminated water, loss of control of flowback, induced seismicity, which we'll get to in a bit, from brine disposal wells. Total water use for life of field may be large. Fresh water is not returned to streams or aquifers. Impact may be larger on headwater streams. Reduced stream flows may affect habitats and endangered species. So hydraulic fracking is a good way to invent a whole bunch of straws to literally suck water out of a watershed without knowing what the consequences will be in the long term. Here's something else that really concerns the U.S. Geological Survey. You're taking millions of gallons of water and frac fluid, and you're putting it down there. What the hell is happening to all that water? We know that some of it is produced back. You know, might be some 40, 50, 60% in some cases. Varies from formation to formation. But what the hell is happening to all the stuff that we leave down there? Where's it going? Scientists at the U.S. Geological Survey don't know, and they think it's a pretty damn important question. Now, are regulators concerned about this? Well, not really. It doesn't seem to be. Here's what they're pushing for. Regulatory changes may be necessary to allow for new water storage options to accommodate hydraulic fracturing operations. Also noted was the need to change the permitting of water withdrawals from burrow pits to facilitate the use of surface water runoff. They're trying to figure out how to do what the rest of the continent is up in arms about. Land fragmentation. Don't need to say much about this. Here's landscape impacts in Pennsylvania. This is where they're drilling for the Marcellus Shale formation. Look at that fragmentation. Here's a Barnett Shale in Texas. Look at the landscape. And you could proudly say that Canadians helped make that landscape because Encana is one of the major companies down there. Here's the Jonah Field in Wyoming. This is another Encana sculpture. That's what it looks like from outer space. You know, aliens are probably, what the hell are these folks doing down there? But the RCB has plans for you. The RCB has proposed to remove subsurface well density controls for CBM and shale gas reservoirs. They want Alberta's landscape to look like Wyoming, to look like Pennsylvania, to look like Texas. Now what about all the truck traffic? anyone that lives in a frack play can't believe the number of trucks going by. The trucks with sand, the trucks with the hydraulic fluid, the trucks with the horsepower on them. It is just truck after truck after truck. I've talked to people in northern BC who've counted as many as 600 to 800 trucks per frack on the wells by their homes. This is from a study done in the European Union suggesting that for a single well pad that's going 4,000 meters deep and with a horizontal well that goes about 1,800 meters, that you could experience 800 to 2,000 truck trips as that well is being fracked. And my question is, who the hell is going to pay for the road repair as a consequence of that kind of heavy traffic? Are we subsidizing that too? Now, what about fracking and what happens down there? What do we know about these fracks and where do they go when we let off these explosive charges and then send down this high-pressured volumes of fluid to break open these sandstone formations? Well, the only thing we really know is that there's a lot of what scientists call non-linear chaos. We don't know where all the fracks are going. We can't control them all. Now, here's a guy who's involved in fracking in the Bakken play. Again, this is a tight oil play in Saskatchewan and in North Dakota. And so here he gave a presentation about fracking, and it has a lot of insights. And he says, look, the fracture is key to the development of these tight reservoirs. And you can see where they're going. I mean, they want to achieve that kind of frack formation. There's no guarantee they're going to get there, and so it's an experiment to work that out. Here's what I love this. He says, fracks are the most poorly understood and poorly optimized element of the well. Uncertain science. And then he goes on to say, well, what happens if you can't control these fracks? Well, you know, and at least 4 treatments have fracked into offset wells 1,500 to 2,000 feet away in a transverse direction, where they've been pumping frack fluid and sand back to surface. Totally unexpected. Totally uncontrolled. Here's a professor at Cornell University, Anthony Angraffia, perhaps one of the world experts on this issue. And here's what he has to say. Since the gas shales, or oil shales, are typically overpressurized, and since the fracking process further increases the pressure in the rock mass for a short period of time, it is possible that the fracking process could open up a pathway towards fresh water. Found the same thing in British Columbia, where they've had 18 what they call fracture communication incidents. This is where one company is fracking away, and another company is saying, "Oh my God, your frack fluid is coming up in my well. What the hell is going on here? And how did it communicate with my well? And it's not, your frack wasn't supposed to do that." Nonlinear chaos. Now, what about earthquakes? All right, you're shaking the ground with this activity. And in fact, I mean, you are basically creating mini earthquakes in the ground to shatter this shed. So are we then going to create major earthquakes above ground as a consequence? The Americans were the first to do research on this. They did so at the Rocky Mountain Arsenal in Colorado in the 1960s, where they were taking chemical and biological waste and they were injecting it into deep formations nearly 2 miles under the ground. They did so and they triggered a whole bunch of earthquakes. And they noticed that the amount of fluid told them was a predictor in terms of the severity of the earthquakes they were recording on the Richter scale.